Curriculum Design Overview for Acts 1 through 4. 4 years of curriculum have been created. Act 1, Create, provides a foundation to scratch and introduces the computational concepts of sequence, events, and loops. The project topics include Name Poem, About Me, and Dance Party. Act 1 is suitable for 3rd to 5th grade students. Act 2, Design, reviews the basics of Scratch and guides students through animation, loops with conditions, parallelism, synchronization, and variables. The project topics include animating a story, creating a maze, creating an animated dialogue between 2 characters, and creating a game. Act 2 is also suitable for 3rd to 5th grade students. Act 3, Impact, focuses not only on computational thinking, but also on environmental literacy, data science, and the concepts of systems. Students learn about ecosystems, invasive species, and the impact trees have on a community. Students create and conduct surveys in their community and analyze and report on the data that they collect. Students apply the following computing concepts as they develop their projects: variables, loops with if, then, else conditions, and functions. Act 3 is suitable for 5th grade students. Act 4, Code AI, consists of 53 AI engineering lessons that use the Scratch-like coding environment called Create a Code. Create a Code expands visual coding capabilities with custom blocks to support AI concepts, as well as using AI for coding assistance and image generation. The curriculum supports educators in guiding students through foundational AI literacy, creative coding, and computational thinking, providing a practical and engaging entry point into AI education for middle school learners. Act 4 is suitable for 6th through 8th grade students. Acts 1 through 3 follow a similar structure, consisting of 4 or 5 units broken down into 2 or 3 lessons each. Each lesson contains engaging and hands-on activities to promote differentiated learning and student engagement. Here are some descriptions of the learning activities that you would find in Acts 1 through 3. In Lesson 1, you have an Intro to Concepts. The aim of this section is to introduce the unit's key concepts in a couple different ways. First is to make a connection between the students' everyday lives and the target concept. Unplugged. The aim of this activity is to provide an example of the target concept in a non-digital context. This type of activity appeals greatly to kinesthetic learners, but it is a fun, game-like way to learn and practice the unit's key concept. Memorable role model. The aim of this activity is to introduce students to people from diverse backgrounds who have made an impact on the world through computer science, to think about what we can learn from other people, to illustrate a quality that often accompanies success in the field of computer science, to encourage students to develop a sense of identity as a computer scientist by seeing themselves in the mentors that they are introduced to, and lastly, to interact with these ideas through listening, reading, and speaking. Lesson 2 learning activities include exploring a CS concept. The aim of this section is to go a little deeper, exploring the unit's target concept. There are exercises that the students work through to identify if they are understanding the concept or not. The class then works through these exercises together. Tip and See. The aim of this activity is to guide students through an existing Scratch project and to teach them to identify what a project does and the code that makes it work. Students will make small modifications to the project to understand how the newly learned computer science concepts work. Lesson 3 learning activities include Quest. The aim of this section is for students to start coding using the computer science concepts that have been introduced in the unit. Students are given instructions on how to modify and create new code in a project that they explored previously using Tip and See. Plan. The aim of this section is for students to plan their unique projects. Sentence frames are provided on the slides to help students communicate effectively and appropriately with each other. The checklist or rubric is presented in this lesson. The rubric offers differentiation for all students. Lesson 4 learning activities. Debugging. The aim of this section is to demonstrate common coding issues or bugs that have been identified over the years of implementing and testing the curriculum. Students are presented with code that does not run correctly and are encouraged to identify the problem, devise a solution, then implement and test the solution until the code runs as expected. Build. The aim of this section is for students to build their unique projects using the planning pages that they created in Lesson 3. This section tends to take the longest as students are developing their projects and thinking of more and more ways to improve them. Lesson 5 learning activities. These are the final activities in each lesson. Vocabulary review. The aim of this section is to reinforce the computational thinking vocabulary that was introduced during the lessons and for students to provide examples of how they applied the computational thinking concepts in their project work. Reflection journal. The aim of this section is to guide students to reflect on their experience of planning and building their unique project in each unit. Sentence frames are provided for each question to help students articulate their thoughts. There is a reflection journal at the end of all but the first unit because the first unit does not include a planning and build activity. Classmate comments. The aim of this section is threefold. First, to give students the opportunity to have an authentic audience for their completed build project. Second, to receive feedback about their projects from their classmates and use this feedback to improve future projects. And third, to get ideas from their classmates' projects to improve or add to their own projects.